I want you to imagine something for a second. If you are, if you're wearing a waterproof jacket right now,
Mm.
or maybe, maybe you just drove a car today with a rust-proof steel frame.
Which, I mean, most of us probably have.
Right, exactly. So the underlying technology that's keeping you dry or, keeping your vehicle intact, it wasn't actually conceptualized in some modern sterile laboratory with guys in white coats.
Not at all.
No, the foundational mechanics for those materials were actually invented over 1,300 years ago. And here's the crazy part. They were invented by a guy who was actively trying to use early chemistry to turn cheap metal into gold.
He was chasing a complete fantasy.
He really was. So today we are taking a deep dive into two comprehensive historical retrospectives. We're looking at the life, the laboratory practices, and honestly, the pretty tragic downfall of a guy named Jabir Ibn Hayyan.
Or, as he's often known in Western texts, Gubber.
Right, Gibber. And our mission today is really to figure out how this happened. We want to know how a person goes from, chasing the impossible dream of alchemical transmutation.
Literally trying to cook up gold from scratch.
Right. How he goes from that to accidentally establishing the empirical foundations of modern chemistry.
It's just wild because we're talking about the synthesis of the first mineral acids here. We're talking about the invention of precise distillation tools.
It's a huge leap.
A massive leap. From theoretical philosophy straight into applied industrial engineering in the 8th century, no less.
Okay, let's unpack this from the very beginning because the timeline here starts in the Khorasan region, which is specifically the city of Tus in what is now modern-day Iran.
Right.
And the texts we are reviewing, they actually highlight a bit of a discrepancy right out of the gate, depending on which manuscript you're looking at. His birth year is cited as either 702 AD or 721 AD.
Which is a pretty big gap. 19 years is a lot.
Yeah, it is. But the exact year is arguably less important than the geopolitical reality of that Khorasan region at the time, because things were tense.
Oh, volatile is probably a better word. It was an incredibly volatile environment. You had the ruling Umayyad Caliphate, and they were facing massive systemic pushback.
Yeah, the sources make it clear that people were just fed up.
Exactly. You had a general populace in Khorasan dealing with heavy taxation, social stratification, just a lot of political disenfranchisement.
Especially among the non-Arab Muslims, right?
Right, exactly. They felt extremely marginalized by the Damascus-based administration. And all of this localized frustration, it essentially coalesced into support for the Abbasid movement.
Which was this massive revolutionary front gathering momentum in those eastern provinces. And we should point out, we are just reporting the historical political context here from the text as factual background.
Yeah, definitely. We're not taking any sides on 8th century caliphate politics here. We're just setting the stage.
Right, just laying out the facts. And the crucial fact here is that Jabir's father, Hayyan bin Abdullah, who is also referred to as Ahmed in some texts, he was right in the middle of this rebellion.
He was. And the sources refer to his father as an attar.
Which translates roughly to, what, an apothecary?
An apothecary, a pharmacist, or a healer. And this is a really crucial detail because an attar in the 8th century, I mean, they weren't just handing out prepackaged pills.
Right, they had to actually make the stuff.
Exactly. They were highly skilled botanists. They were practical chemists. They had to know how to extract active compounds from plants, how to manage dosages.
Basically, they had to mix natural materials to actually provoke a physiological response in the body.
Right. They had a deeply empirical, hands-on understanding of the physical world. Hayyan was a guy who made his living observing cause and effect in nature.
But, his involvement in the Abbasid rebellion kind of shifted his focus. He went from the mortar and pestle to political subversion.
He did. He became an active operative against the Umayyad government.
Which, unfortunately, proved to be a fatal calculation. The Umayyad state apparatus identified him, they arrested him for treason, and they executed him.
And Jabir was just an infant when this happened, when his father was killed.
It's incredibly dark. And, the text frames this as just a historical sequence of events. But the immediate consequence is that Jabir and his mother are forced to completely flee Khorasan.
They literally become political refugees overnight.
Right. They travel all the way down to Yemen to live in exile with their maternal family. And that is a massive geographic displacement.
Oh, huge. Not just in terms of the physical distance, but in how it completely severs Jabir from any traditional path to power, or even just social stability that he might have inherited.
Yeah, he is stripped of his patrimony. He loses his geographic roots.
What's fascinating here is the psychological implication of that early exile. It really forces him into a very specific kind of existence.
How so?
Well, he grows up on the margins, He isn't being groomed for a political administrative role in some new regime. He is essentially observing the world from the outside.
Wow, yeah. I really wonder how much of that political trauma directly informed his scientific methodology later on.
It's a great question.
Because if you think about it, it's almost like a superhero origin story, right?
Hmm.
You watch the human systems around you fail so spectacularly. Your father is executed by the state. You lose your home.
Your whole early life is dictated by chaos.
Right, the chaos of a volatile rebellion. It seems entirely logical that you would turn your back on the arbitrary, unpredictable rules of human politics. You want to find rules that cannot be broken.
Yes, exactly. It is the search for immutable laws. I mean, a caliph can rewrite a tax code, right?
Right.
Or they can order an execution. But a caliph absolutely cannot change the boiling point of water.
Oh, that's such a good point.
They cannot alter the specific gravity of lead. When the social order proves to be lethal and chaotic, the natural order offers this rigid, predictable sanctuary.
It's a
Exactly. And you see this pattern repeatedly in the history of science. You have individuals displaced by political upheaval who just turn toward the absolute certainty of mathematics or material science.
And for Jabir, that search for absolute certainty begins with his formal education, which, according to the sources, is just overwhelmingly extensive.
It really is.
While he is in Yemen, he is placed under the guardianship of a scholar named Harbi al-Himyari. And under this tutelage, he learns the Quran and the foundational religious sciences.
Which was standard for rigorous education at the time.
Right, but his intellectual trajectory really accelerates when he is eventually sent to live with relatives in Kufa.
Kufa was incredible. It was rapidly becoming one of the most vital intellectual hubs in the entire Islamic world.
A total melting pot of ideas.
A crucible of intellectual synthesis. When he arrives, he enrolls in a madrasa and eventually becomes a prominent student of the great Imam Jafar al-Sadiq.
And this is where his curriculum expands into what we today would consider an unimaginably broad polymathic education. I mean, the texts say he is studying philosophy, formal logic, medicine, astronomy, poetry, linguistics, and music.
All at the same time?
All at once. And he even masters the Greek language specifically so he can read the ancient texts in their original forms.
Right, so he can read Aristotle, Plato, and the Hellenistic alchemists of Alexandria without relying on translations.
Which is amazing.
Yeah.
But I have to push back a little on the utility of this curriculum.
Okay, how so?
Well, I understand the value of reading Greek.
Yes.
You not access Aristotelian elemental theory. But practically speaking, how does studying poetry or plucking a lute string actually help you figure out the physical properties of metals in a laboratory?
It seems disconnected to us.
Yeah. I mean, isn't there a point where studying music is just a distraction from learning chemistry?
So from a modern, hyper-specialized perspective, it absolutely looks like a distraction. But within the philosophical framework of the Islamic Golden Age, it was the exact opposite. Yeah. They operated on this deeply entrenched belief in the interconnectedness of the macrocosm and the microcosm. To them, the universe was not a collection of isolated, fragmented disciplines.
Like we have today, with biology over here and physics over there?
Exactly. To them, it was a cohesive, rational structure governed by underlying mathematical and logical ratios.
Okay, so they believe the rules governing a musical scale also governed physical matter.
Precisely. It actually traces all the way back to Pythagorean concepts of ratio and harmony. Think about it. If you plug a string, it produces a specific pitch.
Right.
If you have the length of that exact same string, it produces a pitch exactly 1 octave higher. That is a 2-to-1 mathematical ratio physically manifesting as an audible harmony.
Oh, well, I see where you're going with this.
So for a mind like Jabir's, music was not just auditory art, it was the audible expression of mathematics. He believed that if you could understand the mathematical structures that make a musical chord resonate, you were literally training your brain.
Training it to do what?
To recognize the hidden ratios required to combine physical elements into stable compounds.
That is wild. Okay, that makes total sense regarding music. But
Yeah.
what about linguistics? Because the sources heavily emphasize his deep study of the structure of language.
Well, the study of Arabic linguistics is incredibly systematic. Arabic is based on a root system, usually consisting of 3 consonants.
Right.
And by applying specific morphological rules like adding vowels, prefixes, or suffixes, you can transform that single root into dozens of different words with related meanings.
Like a formula.
Exactly like a formula. It is a highly logical transformational matrix. Jabir looked at the morphological transformation of language and saw a direct analogy for the transmutation of matter.
Oh, man. So if you understand the rules of how a base root word can be transformed into a complex noun,
You are priming your logical faculties to understand how base matter might be transformed into a noble metal through specific chemical interventions.
so he isn't just learning trivia. He isn't just taking electives.
Not at all.
He is actively building a mental framework, like a unified field theory of logic, where the rules of grammar, the ratios of music, and the behavior of elements are all just different expressions of the exact same underlying universal code.
Exactly. He is meticulously training himself to recognize systems and patterns in everything. And then he takes this massive interdisciplinary theoretical framework and he drops it right into the most practical, hands-on environment possible.
The Street of Goldsmiths.
Street of Goldsmiths in Kufa.
Yeah, the texts refer to it as Sukkah Saga. His family permanently settles in Kufa, and this specific neighborhood basically becomes the absolute catalyst for his life's work.
It really is the turning point.
Here's where it gets really interesting, because you have to imagine the sheer physical intensity of this place. The Street of Goldsmiths was the epicenter of metallurgy. It's packed with artisans, jewelers, blacksmiths, and most importantly, alchemists.
It was essentially an 8th century Silicon Valley. But instead of coders, it's innovators, hustlers, and dreamers all chasing the ultimate startup idea.
Unlimited gold.
Unlimited gold. It was an environment defined by extreme heat, the constant grueling manipulation of materials, and this relentless pursuit of transmutation.
And the primary focus of alchemy at this time was very specific, right?
Very. It was the attempt to transmute cheap, abundant base metals like copper, lead, or tin into precious noble metals. Specifically gold and silver.
And I want to be really clear about Jabir's stance on this, because it is so easy for us to look back with modern hindsight and assume a genius like him knew it was a fool's errand.
Right, that he was above it all.
Yeah, but the sources are explicit on this point. Jabir firmly and unequivocally believed transmutation was possible. He wasn't the skeptic standing in the corner taking notes.
He was leading the charge.
He was dedicating massive amounts of time, energy, and resources to cracking the code of artificial gold.
And we have to understand why he believed that. Because within the Aristotelian framework he was operating under, transmutation was entirely 100% logical.
Break that down for us. What was the Aristotelian framework?
So Aristotle posited that all matter was composed of one primary substance, and it was differentiated only by 4 qualities: hot, cold, wet, and dry.
Okay.
And metals specifically were thought to be generated inside the earth by 2 exhalations: a smoky, earthy exhalation, which was associated with sulfur, and a vaporous, watery exhalation associated with mercury.
So it's all sulfur and mercury under the hood.
Basically, yeah. The theory was that all metals are essentially made of the exact same coarse stuff. They are just mixed in different ratios, and they have varying degrees of purity.
So in their minds, copper and gold are practically cousins.
Exactly. Copper isn't a fundamentally different element on an atomic level. I mean, they didn't know about atomic nuclei or protons or any of that.
Sure.
To them, copper was literally just gold that hadn't cured properly in the earth. Or maybe it was gold that had the wrong ratio of what they called accidents, which were the temporary qualities of a substance.
So the alchemist's job was simply to fix nature's mistake.
Exactly. Their job was to strip away those impurities in a laboratory, adjust the ratio of hot, cold, wet, and dry, and encourage the metal to reach its most perfect state, which was gold.
So they are throwing copper into furnaces, treating it with salts, exposing it to sulfur vapors, cooling it down, reheating it, just trying to trigger this perfection over and over again.
Over and over.
But scientifically, we know today that this is a thermodynamic impossibility. You cannot change a copper atom into a gold atom using an 8th century furnace.
No, you absolutely cannot.
You need the energy of a particle accelerator, or literally a supernova, to alter the number of protons in a nucleus.
Which means, practically speaking, every single attempt Jabir made to create gold was a failure. Every single one.
But this is where the history of science pivots.
Right.
Because even though he couldn't make gold, his rigorous, exhaustive methodology forced him to document exactly what did happen.
Yes. If we connect this to the bigger picture, The failed pursuit of transmutation is what birthed the empirical science of chemistry. Because Jabir didn't just throw things in a pot and hope for the best.
Right, if you heat copper with a specific salt and it turns green, it's not gold, but it is a reproducible reaction.
And that reproducibility is the absolute key. It's everything. Jabir completely moved away from the mystical, esoteric incantations that characterized earlier alchemy. He demanded rigorous empirical observation.
The source text actually highlights a specific defining moment for him in the lab.
Yeah, the stone.
Right. He observed a particular stone change color during a controlled experiment. And this seemingly minor visual shift just completely catalyzed his understanding that chemical change is a physical property reacting to a specific stimulus. It's not magic.
And mechanical.
Yeah.
Yeah.
He realized that to truly understand these changes, he had to categorize and isolate the processes.
And he categorizes them brilliantly. I mean, the sources detail how he begins defining the specific isolated processes of chemistry that we still use today. Well, he codifies sublimation, for one.
Which is turning a solid directly into a gas without it becoming the liquid first, right?
Exactly, like dry ice. He also masters crystallization, understanding how dissolved substances precipitate out into geometric structures.
But as he is isolating these processes, he runs into a massive logistical wall. The theoretical concepts in his head are drastically outpacing the physical hardware he has in his lab.
You just cannot perform precision, isolated chemical reactions using open cauldrons and porous earthenware pots. The tools for pure chemistry simply did not exist yet.
So he invents them, which leads to his greatest physical invention, the alembic, or the alembic in Arabic.
The alembic.
The texts describe this device, and it is effectively the direct ancestor of the modern distillation apparatus. I mean, think of your classic chemistry lab beaker setups.
Right, the glass tubing and everything.
Exactly. It was made of specialized, highly refined clay, or sometimes glass, and it was deliberately chosen so the vessel itself wouldn't react with the chemicals inside it.
Which is a huge leap in logic right there.
Huge. It featured a lower cupping glass, sometimes called a cucurbit, where the material was heated, and then it had an upper head with a long, downward-sloping tube that led to a totally separate receiving vessel.
The invention of the alembic just completely revolutionized the manipulation of matter. It allowed for highly controlled distillation. And to understand why that matters, we really have to look at the mechanics of distillation itself, because it is essentially a thermal sieve.
Let's break down how that thermal sieve actually works, because it's not just, boiling water to make pasta.
No. It relies on the differential vapor pressures and boiling points of mixed liquids. So imagine you have a complex mixture of liquids and plant materials.
Okay, I'm picturing it.
When you apply heat to the lower chamber of the alembic, the substance within that mixture that has the lowest boiling point will vaporize first. Always.
Right, it turns into a gas before anything else does.
Exactly. It turns into a gas, leaving the rest of the mixture behind as either a liquid or a solid. That specific vapor then rises into the cooler upper chamber of the alembic.
And because it's cooler up there,
Yeah.
it condenses.
Exactly. The drop in temperature causes it to condense back into a purified liquid state. It gathers on the sides of the glass, and then it drips down that long tube into the receiver.
So you are systematically pulling the mixture apart, literally molecule by molecule, based on how much heat energy it takes to turn them into gas.
It's elegant. And Jabir initially used this to extract extremely concentrated herbal essences and essential oils.
Going back to his father's roots as an apothecary.
Precisely. By distilling plant matter, he was isolating the active medicinal compounds from the inert fibrous material. He was creating highly potent, stable liquid medicines that wouldn't spoil over time.
Which alone was a massive leap for pharmacology. I mean, that changes medicine forever.
Absolutely.
But he didn't stop at plant extracts. The real paradigm shift happens when he takes this advanced distillation technology and he applies it to aggressive, highly reactive mineral compounds.
This is the heavy stuff.
This is how he synthesizes what I consider the absolute backbone of modern industry, the strong mineral acids.
This is perhaps his most consequential legacy. Because prior to Jabir's synthesis of mineral acids, humanity was fundamentally limited in how it could alter the physical world.
Like, what was the strongest acid they had before this?
The strongest solvent available was essentially acetic acid, which is just vinegar.
Just vinegar. Wow.
Yeah, you could physically smash materials, you could burn them in a fire, or you could carve them, but you absolutely could not fundamentally dissolve them at a molecular level.
And the sources explicitly detail his synthesis of sulfuric acid, nitric acid, and hydrochloric acid And the sheer mechanical difficulty of doing this in the 8th century is mind-blowing.
Oh, it's incredibly dangerous.
Let's look at sulfuric acid as an example. You don't just find a puddle of sulfuric acid out in the woods.
No, nature doesn't just hand that over. It requires dry distillation of sulfates at extreme temperatures.
How extreme.
Well, Jabir would take green vitriol, which is iron, 2Y, sulfate, and alum, and he would heat them in a specialized furnace to temperatures exceeding 400 degrees Celsius.
400 degrees.
Yeah. And at that temperature, the vitriol undergoes thermal decomposition. It starts releasing highly toxic, highly corrosive sulfur trioxide gas.
Okay.
He then had to capture that invisible toxic gas in the alembic and essentially dissolve it into water to form liquid sulfuric acid.
The precision required there is terrifying. I mean, one slip and you're dead.
Oh, without a doubt.
And then, to make nitric acid, he takes that freshly made sulfuric acid and he distills it with saltpeter, or potassium nitrate. And to make hydrochloric acid, he reacts the sulfuric acid with common table salt, sodium chloride.
He is systematically building a chemical arsenal from scratch.
But I have to ask about the physical reality of this.
Yeah.
Because the texts mention him breathing in sulfur and chemical vapors daily.
Yeah.
If you are heating sulfates to 400 degrees and releasing sulfur trioxide gas in a poorly ventilated 8th century mud brick room, how does he not die instantly?
Honestly, it is a minor miracle he survived as long as he did. It speaks to a profound physical tolerance that he must have built up over decades, coupled with extreme, albeit rudimentary, caution.
Because there's no safety gear.
None. The occupational hazards of this laboratory were severe. Think about it. Sulfur trioxide gas reacts instantly with moisture to form sulfuric acid.
Right.
So if you inhale that gas, it reacts with the natural moisture in your respiratory tract. It literally creates sulfuric acid inside your lungs, causing severe chemical burns.
Oh, that is horrific.
And nitric oxide gas, which is a byproduct of the nitric acid synthesis, does the exact same thing. And remember, there were no fume hoods. There was no standardized personal protective equipment, no goggles.
So he is literally sacrificing his cellular health, his own body, to extract these compounds.
He is.
He is in this dark, smoke-filled room dealing with exothermic reactions. The texts mention him creating mixtures that emitted intense, localized steam and heat without any fire present.
Which would look like literal magic to anyone watching.
Absolutely. He's playing with the fundamental forces of molecular bonds. But, and this is huge, but he wasn't just hoarding this knowledge as some kind of theoretical parlor trick.
No, and that is the crucial distinction between a pure academic philosopher and an applied scientist. Jabir recognized that these newly discovered chemical processes had immediate, massive industrial applications.
Real-world problem solving.
Exactly. He took the theoretical understanding of matter completely out of the laboratory and applied it directly to manufacturing. He initiated what the sources essentially describe as an 8th century chemical industrial revolution.
Let's talk about those applications, because think about your waterproof jacket or the rust-resistant frame of your car. Jabir was writing the manual for these technologies 1,300 years ago. These are things that directly affect how empires function.
They absolutely are.
For instance, the texts note he developed advanced chemical methods to dye leather.
Right. And he didn't just paint the leather. He figured out how to use chemical mordants, which are often metallic salts, to actually bind the dye molecules directly to the protein fibers of the leather.
Making the colors incredibly vibrant and, more importantly, permanently resistant to fading or washing out.
Yes. And he also tackled the fundamental degradation of materials. He developed processes to waterproof common cloth.
How did he do that back then?
Well, it likely involved applying hydrophobic lipid or wax emulsions that adhered to the fibers. He was fundamentally altering the surface tension of the fabric. So instead of absorbing water, the water would just beat up and roll off.
It's brilliant. But the most geostrategically important invention mentioned in the sources is his work in metallurgy, specifically his methods for rust-proofing iron and his contributions to the manufacturing of steel.
The rust-proofing of iron is just an incredible feat of applied chemistry, because rust is an electrochemical process. It is oxidation.
Right. The iron is breaking down.
Exactly. Iron atoms are actively losing electrons to oxygen molecules in the environment. And that process is accelerated heavily by the presence of water, which acts as an electrolyte. The iron lattice literally degrades as iron oxides form and flake away.
So how on earth do you stop that electrochemical process in the year 750 AD?
You have to intervene at the molecular level. You have to create a dielectric barrier. a physical layer of material that prevents the exchange of electrons and physically blocks the moisture and oxygen from ever reaching the iron lattice in the first place.
And he figured that out.
He did. Jabir experimented with organic varnishes. He utilized specific combinations of polymerized oils and resins. When these were applied to heated iron, they would chemically bond to the surface and cure into this hard, completely impermeable shield.
Wow. And his work on steel manufacturing is equally impressive, because making steel isn't just about getting iron really hot and melting it. It's actually all about carbon control.
Carbon is the key.
Right. Wrought iron is soft because it has way too little carbon in it. Cast iron is super brittle because it has way too much. Steel sits in that perfect, incredibly narrow middle ground of about 1% carbon.
Exactly. And the sources indicate Jabir was actively manipulating the carbon matrix of the iron lattice. He was using controlled heating and introducing carbon-rich materials during the actual smelting process.
Which requires an astonishing leap in human intellect.
It does, because if you step back and look at the aggregate impact of these practical applications, the leather, the waterproofing, the rust-proofing, the steel, you are looking at a fundamental shift in a civilization's capabilities.
It's an insane tactical advantage.
Think about it from a military perspective. If you can mass-produce steel swords that are harder and hold a sharper edge, and you can varnish that steel so your military equipment doesn't rust during a long, wet campaign.
And your soldiers have waterproof canvas for their tents and waterproof leather for their saddles.
Exactly. You possess a massive, almost insurmountable strategic advantage over your neighbors.
So you aren't just a quirky guy in a lab anymore. You are a state asset.
A highly valuable state asset.
And that level of applied, military-adjacent technological success absolutely draws the attention of the ruling elite, which is exactly what happens next in the timeline. Jabir's fame reaches Baghdad.
The sprawling, wealthy, intellectual capital of the Abbasid Caliphate.
Right, which is currently under the rule of Caliph Harun al-Rashid. And Harun al-Rashid, along with his son later on, they basically built the House of Wisdom.
Right. Harun al-Rashid's court was arguably the absolute center of the world's wealth and scientific patronage at that time.
And the Barmakid family, specifically the vizier Jafar al-Barmaki, they recognize Jabir's value. So they extend a formal invitation for him to leave Kufa and join the inner circle of the court in Baghdad.
Which is the absolute pinnacle of scientific prestige. You cannot get higher than this.
The sources outline this period as being incredibly highly productive for him. He is heavily compensated, he is deeply respected, and he dedicates several books specifically to the caliph. But there is one specific anecdote detailed in the historical retrospectives that perfectly encapsulates the friction between his advanced chemistry and the medieval mind.
This is such a great story.
The caliph, having heard all the rumors of Jabir's prowess, demands a physical demonstration.
He wants to see the laboratory translated into a spectacle for the court.
Right, he wants to see the magic. So what does this all mean? Let's picture the scene.
Jabir stands before the caliph and the assembled nobility of Baghdad.
Right.
He takes a solid piece of metal and he places it into a clear glass vessel. He then takes a vial of a clear liquid, which is almost certainly one of his newly synthesized strong mineral acids, likely nitric acid if he was dissolving something like copper or silver.
Most likely, yeah.
And he pours it over the metal.
The chemical reaction would have been immediate and incredibly violent.
Just bubbling and fizzing.
Yeah. The acid attacks the metallic bonds. In the case of nitric acid reacting with a metal, it actually oxidizes the metal atoms. It turns them into soluble metallic salts that literally dissolve into the water.
Just vanishing into the liquid.
And not only that, the reaction also releases nitrogen dioxide gas, which bubbles violently and produces this dense, toxic, reddish-brown vapor that would pour out of the glass.
So, to the caliph, standing there in the 8th century, he isn't seeing an electron transfer. He doesn't know what oxidation is.
He is watching a solid, indestructible piece of metal bubble hiss, spew colored smoke, and completely vanish into a clear liquid.
It's mind-bending for them.
The text actually notes the caliph's reaction. He is stunned, and he immediately calls it magic.
And from an epistemological standpoint, the caliph's reaction is completely rational.
Really? You think so?
Oh, absolutely. Think about it. Up until that exact moment, the only thing in human experience that could melt metal was a roaring, massive furnace.
Oh, all right.
And even then, in a furnace, the metal simply changed state from solid to liquid. It didn't disappear, and it hardened again as soon as it cooled down.
That's a great point. It didn't just turn into water.
Right. So to see a room temperature liquid obliterate a solid piece of metal, that violates every single rule of physical reality that Caliph has ever known. To him, it has to be sorcery. There is no other explanation.
But Jabir refuses to let that stand. He refuses to be categorized as a magician.
He corrects him right there.
The sources, quote, his exact response to the emperor. It is not magic, but the science of chemistry, achieved through intellect given by Allah.
Which, this raises an important question because that is a profoundly bold and honestly dangerous statement to make to an absolute monarch.
Yeah, you don't really correct the caliph.
Exactly. But he is demystifying the power. He is telling the caliph, look, there is no supernatural intervention happening in that glass. There are only the mechanical laws of nature, and through rigorous intellect and observation, a human being can learn to manipulate them.
He is trying to prove that the physical world operates on logic. And he actually spends the rest of his life documenting those laws. The texts state he wrote over 500 books.
500? That's a staggering output.
It's unbelievable. They list specific titles, too, like the Book of the Hidden Secret, the Great Book of Properties, and the Book of Mercy. He is trying to codify absolutely everything he has learned into a permanent, reproducible manual for humanity.
He wants to ensure that the next generation doesn't have to start from scratch in the dark.
Right. But, that interaction with the caliph exposes the fundamental vulnerability of Jabir's position.
It really does. When your understanding of the physical universe is centuries ahead of the society you live in, your science is completely indistinguishable from magic to the layperson.
And people fear magic.
They do. And as long as you have the political protection of a powerful vizier, you are safe. But the moment the political winds shift, that perception of magic becomes a lethal liability.
And the political winds in Baghdad always shift. The historical sources note that the Barmakid family, the very powerful viziers who had brought Jabir to court and protected him, they eventually suffered a massive, catastrophic fall from grace.
It was abrupt and brutal.
The caliph turned against them entirely. He executed Jafar al-Barmaki and imprisoned the rest of the family. And just like that, overnight, Jabir lost his political shield.
Without the patronage of the Barmakids, the court became incredibly dangerous for him. He was suddenly exposed. He was forced to flee Baghdad and return to Kufa, attempting to just live a life of quiet seclusion and continued study.
But he couldn't hide. His reputation as the man who could dissolve solid metal, the man who manipulated the hidden properties of matter, it followed him.
You can't put that genie back in the bottle.
The texts explain that the general populace and the new political authorities in Kufa were deeply suspicious of him. Which makes me wonder, was this suspicion purely rooted in scientific ignorance? Or was it just a convenient political excuse to neutralize someone who used to be associated with the disgraced Barmakid regime?
It was almost certainly a toxic combination of both. His association with the Barmakids automatically made him politically suspect, but the sheer incomprehensibility of his work gave his enemies the perfect weapon to use against him.
They didn't even have to accuse him of treason.
No, they accused him of something far more visceral, something far more terrifying to the general public. Despite all his books, despite his constant insistence on empirical logic, he was formally accused of using his scientific research as a front for practicing actual dark magic and sorcery.
It is just incredibly sad. The ultimate tragedy of his life is that the very rationalism he championed was used to condemn him. The authorities imprisoned him based on these accusations of magic.
The irony is painful.
It really is. The man who dedicated his entire existence to proving that the universe operates on predictable, testable laws is locked in a cell by people who are just terrified of the unknown.
And his final years in confinement were physically agonizing. The decades of relentless, unprotected laboratory work we talked about, it finally exacted its toll.
His body just gave out.
Yeah. We discussed the toxicity of the gases he was generating, the sulfur dioxide, the sulfur trioxide, the nitrogen oxides.
Right.
Well, when those gases chronically contact the mucous membranes of the eyes over years and years, they form localized microscopic amounts of sulfuric and nitric acid directly on the cornea and the conjunctiva.
Oh man, so it's burning his eyes every single day.
Exactly. And the sources detail that he went completely blind in prison. It was a cumulative result of severe chemical burns to his retinas and corneas, combined with the extreme strain of exhaustive reading and writing by the dim light of oil lamps.
The very chemicals he discovered literally ate away his ability to see the world he was trying to understand.
He died in the year 817 AD at the age of 95.
95. To survive that long after inhaling all that is incredible.
It's astounding. But he died in absolute seclusion, blind and imprisoned by the very society he had tried to drag into a new era of scientific understanding.
There is a quote provided in the historical text from an American professor evaluating Jabir's legacy. He stated, quote, "Blindness took his eyes, but this great thinker gave many things and laid the foundation of true chemistry."
It's a beautiful way to summarize it. Because the authorities could lock up the man, but they couldn't lock up the 500 manuscripts he left behind.
Right. The ideas escaped.
They did. And those manuscripts survived the centuries. They were painstakingly copied, studied, and eventually, during the 12th and 13th centuries, a massive translation movement began in places like Toledo, Spain.
Where they were translating Arabic texts into Latin.
Exactly. Jabir's Arabic texts were translated, making their way into the monasteries and the early universities of Europe. His name was Latinized to Geber, and an entire corpus of subsequent European alchemical and chemical literature was attributed to him.
So, when the European scientific revolution finally kicks into gear centuries later, when figures like Robert Boyle and Antoine Lavoisier begin formalizing the modern laws of chemistry.
They are utilizing distillation techniques, the mineral acids, and the empirical methodology that was pioneered by the blind prisoner of Kufa.
In the Western historical canon, Geber is universally recognized as the foundational architect of early chemistry.
His life just perfectly demonstrates the relentless, often brutal trajectory of human progress. I mean, he was physically ruined by his own discoveries and socially ruined by the ignorance of his contemporaries.
But the truth outlived them all.
Exactly. The empirical truth of his work proved completely impervious to both politics and time.
As we conclude this deep dive, I want you to think about the incredible arc of this story. We started with an orphaned infant fleeing a political execution. We watched him construct this intricate mental model of the universe where poetry and metallurgy followed the exact same rules.
A unified theory.
Right. We stood in that toxic, suffocating laboratory as he engineered the thermal sieves and synthesized the acids necessary to rip apart the molecular fabric of reality.
We saw him shatter an emperor's understanding of the physical world.
And then we watched him die in the dark, punished for the crime of being right.
But as you consider the totality of his work, I really want to leave you with a final thought regarding his ultimate ambition.
Okay, lay it on us.
Jabir Ibn Hayyan spent decades obsessively trying to achieve the alchemist's grandest illusion, transmuting cheap, everyday copper into perfect, invaluable gold. Chemically, physically, he failed completely at that.
Complete failure.
But in the systematic, grueling process of that failure, he codified the empirical laws of chemistry. He gave humanity the tools to synthesize life-saving medicines, to manufacture industrial steel, and to engineer the modern materials that basically define our civilization.
Yeah.
So, did he actually fail? Or, by giving us the power to manipulate the very building blocks of matter, did he succeed in creating something infinitely more valuable than gold?
That is a fascinating perspective.
Because the only difference between magic and science is a mechanistic understanding of the process, which really begs the question. What seemingly impossible magical concepts are theoretical physicists and material scientists working on today that our great-grandchildren will simply consider basic everyday engineering?
That is something to think about next time you put on a rain jacket. Thank you for joining us for this deep dive into the origins of chemistry. Keep questioning the physical world around you, keep looking for the underlying mechanics, and we will see you next time.